Hello everyone, this video I'd like to explain how 6502 Opcodes encoding is working. So in case if you need to do some hand assembling, if you're not using assembler, and if you're looking for an optimized way of how you can memorize 6502 Opcodes so that you could do hand assembling with ease, or at very least if you don't want a huge reference with all the opcodes listed, but want somewhat a short cheat sheet like representation like I have on the left hand side of my screen. In this case, this table that I came up with might be very helpful. So I will show how you can use this table in order to encode opcodes on your very own. So before we start, let's break down all the 6502 opcodes into two parts. So generally we have those opcodes that do follow the pattern, and the pattern is represented here. So AAA, 3 bits, then BBB, another 3 bits, and CC, last 2 bits. So there are opcodes, so all these opcodes are following this pattern when it comes to encoding a certain addressing mode. On the other hand, there are 1 byte instructions for various things like branching, doing things with flags, transferring values between registers, incrementing registers, and doing some stack-related operations, and obviously break and no operation, just references. So these on the right hand side of the table are just the single byte opcodes that you can just remember those. Although there are some patterns like how you can come up with branching opcodes, but still it's just from the perspective of the memorization, just the matter of knowing this exact order. And anyway, this doesn't take much space. But when it comes to these opcodes, so we would be encoding LDA, LDX, and LDY, which are most commonly used. So it's hard to remember all the 1, 2, 3, 4, 5, 6, 7, 8 opcodes for LDA for different addressing modes. It's also not that easy to remember all the 1, 2, 3, 4, 5 LDX opcodes for the 5 addressing modes, and same for LDYs. So with this table, you can easily encode the opcodes on your very own. So without further ado, let's get started. And then by the time I would end up with this, I will open the full reference where all the opcodes are listed, and there we will check whether I did this hand assembling and hand encoding properly or not. So we kickstart with LDA immediate mode. So LDA is the first group, so first group, second group, and the third group. So first group, LDA, starts with 101. So essentially I can do 101 everywhere because all would start with 101, okay? And also they would end up with the same value, which is 01. This is specific to the first group. So here we just have XXX. We don't know what would be there because the addressing mode would be changing. And this 2 last bits would be 01, and this will always be the case. So I can essentially do like this, XXX01, okay, and come up with these codes. We'll then do the same for LDX and LDYs, but for now, let's just fill in the addressing modes for LDA. So, LDA immediate addressing mode. So this group. So addressing modes encoding for the first group and for the second group are not exactly the same, although they're quite similar. So bear this in mind. So we have the immediate mode, the value of 2, 0, 1, 0 in hexadecimal, 0, 1, 0, okay. Then 0 page, 001, 001. Then we have 0 page indexed by X. So 0 page indexed by X is 101, which is 5 in decimal. Then the index indirect, this one 0, 0, 0, 0, 0, 0. Then indirect indexed, this one 100, which is 4 in decimal. And then absolute 0, 1, 1, 2 in decimal, 0, 1, 1. Then absolute indexed by x is 1, 1, 1, decimal 7. Absolute y 1, 1, 0, decimal 6, 1, 1, 0. Okay. Now, in order to make it easier, we essentially want to convert them to hexadecimals. So I just I do the following. So I just get rid of this space, and I also get rid of this space. And now I want to can I do this? Yeah. I want to split them so that it would be easier to encode. Now, so we convert this binary number to hexadecimal. So this is like 2 plus 8 is 10 in hexadecimal A. So this would be A, and this is 1 plus 8 is 9. A9, we got A9. Okay, this one A5. Okay, this one, so A plus 1 would be B, B5, B5. This one is A1, A1, yeah. And this one is, again, B1, B1, great. This is complicated. Okay, so this one is A, and we have, so 1 plus 2 is 5, plus 8, oh my goodness, 13. I'm not good at calculating in my head. Okay, again, let's say 8 plus 4 is 12, yes, plus 1, 13. So A, 10, B, 11, C, 12, D, 13. So AD. Okay. This one should be B, and this one is the same, so BD, and this one is going to be B9. 1 plus 8. Yeah, B9. Okay. We are now done with LDAs. Essentially, we can go further on to get done with LDX kind of stuff. And I'm wondering if I can do all the LDX 101. So 101. Okay, yeah, I need to probably manually enter these. So 101, 101, 101. Okay. And, oh, I'm sorry. The group is, oh, I got a typo in here. Why did I make it? Just a typo. 1, yeah, before I forgot. It's a horrible typo. So all the values in a group are the same. So 0, 1, 1, 0, 0, 0. Okay. Okay. Now different addressing modes. So I hope I can. Okay, no, not for now. So, this one is the immediate mode. Immediate is 0, 0, 0. Then 0 page mode 001, then 0 page indexed by y 101, yeah, 0 page indexed by y, yeah, absolute 0, 1, 1, 0, 1, 1, and absolute index by y 1, 1, 1. Okay. Now similar stuff here. We just want to group them accordingly. So I just do like this, and this is going to be A2. This is going to be A6. This is going to be B6. This is going to be A. All ones is F, minus 1 is going to be E. A, E, A, E, and this one is B, E. Yeah? Okay, looks like it's correct. If I did something wrong, then yeah, we can always check that out. So LD, so this were the LDX, yeah? Now the LDY, so LDY is 101. Oh, interestingly, both are 101. But the difference is these is the group code. So they are both 101, but the group code is different. So 101, 1, 2, 3, 0, 0, and all would be the same. All right, now addressing modes. So what we have here, immediate is 0, 0, 0, okay. Then 0 page is 0, 0, 1. Yep. 0 page index by x 101. Absolute 0, 1, 1. And absolute indexed by x 1, 1, 1. Okay, again, immediate 0, 0, 0. 0 page 0, 0, 1. Absolute. Nope. Then goes 0 page index by x 101. Yep. Absolute 0, 1, 1. And absolute index by x 1, 1, 1. Yeah, seems to be correct. So, what have I done? Now again, group them by 4. Okay, and go and encode. So this is going to be A0. This is going to be A4. This is going to be B4. This is going to be A 12, right? 8 plus 4 is 12. A, B, C, A, C. And this is going to be B, C. Yeah, we are done now. So I just close this one and just open another one. I want to open the README. Yeah. So here I have the full reference. So let's search for LDA. Next. Okay. And I just scroll a little bit so it's seen better. Now, let's do no highlight. So, 0 page immediate is exactly indeed A9. 0 page, LDA immediate, A9. LDA 0 page, A5, which is correct. 0 page index by x, B5. 0 page index by x, B5, which is correct. 0 page indexed indirect. Okay, indexed indirect. this one is A1. This is A1. LDA indirect index B1. Indirect index B1, which is correct. LDA absolute AD. Absolute AD, 0 page absolute index by X BD, and 0 page absolute index by Y is B9. And this is it. So LDA has been encoded properly. Let's move further on. So now we're looking for LDX. Next. Okay, so going for LDX, LDX immediate A2, LDX immediate A2, correct. LDX 0 page A6, LDX 0 page A6, this is it. Then LDX 0 page index by Y, 0 page index by Y is B6, and we got B6 here. Great. LDX absolute AE, and we got AE here. 0 page absolute index by Y, BE. Okay, and we got BE here. Okay, so LDX has been encoded properly. Now let's look for LDY. Okay, so just move this a little bit like in here. So LDY immediate A0, yes. LDY 0 page A4, correct. LDY 0 page indexed by X B4, correct. LDY, sorry, all these LDYs. LDY absolute AC, LDY absolute AC, LDY absolute indexed by X is BC. Now we got BC here. So as you can see, guys, I didn't make a single mistake with this encoding, because it's very simple and straightforward, and it's really hard to make a mistake here. So the only thing you need to know is whether a given instruction, whether a given opcode essentially supports a given addressing mode. So you may encode the opcode that doesn't particularly exist in 6502 opcode list. But yeah, if you understand that, you can not do things like STA in the immediate mode, because physically this does not make sense. You cannot set the value with the A register to immediate data, because the immediate data is not within the random access memory, and ST type of instructions are working with the random access memory to set a value there in one or another way. So yeah, you may encode a code that doesn't exist, but that's not the problem of encoding. That's the problem of not understanding whether the certain addressing mode is working with a certain opcode or not. But regarding just the bare encoding of opcodes, this is kind of it. And I think that it's much better to have a single table. So again, I just want to open the table. So I think it's much better to have this tiny little table instead of this huge file with all the possible instructions. Well, obviously some additional things are added there. So if you don't know how to subtract with carry flag or add with carry flag or things like that, or what's the difference between the arithmetic shift left and the rotating left, then obviously reading through this instructions is very helpful. But yeah, generally, if you know what are you doing, and if you just want to do the hand assembling quickly with those instructions you've been using for years, this might be very helpful and handy. Yeah, guys, so this is it from my side. Thanks for watching. I'll see you in the next video. Until then, and cheers.